Good day, everyone. I am Ria May del Rosario, and I will be discussing the measures of central tendency. So, the measures of central tendency has three means, which is the mean that represents the average of the dataset, the median that represents the middle value of our dataset, and the mode that represents the repeated value in a dataset. So, measures of central tendency or MCT are classified into two, which is the ungrouped and grouped data. So, let's first discuss the ungrouped. So, ungrouped data is uh, sets of raw data sets or raw scores of a dataset. So, in measures of central tendency ungrouped data, we also have formulas for getting the mean, median, and mode. So, for the ungrouped data, the mean is the most frequently used to measure central tendency, and it is found by adding the data values and dividing the total number of values. So for our formula, we have x or x bar that symbolizes mean is equals to summation of x over n, wherein our x is the mean, or x bar is the mean. The summation of x will be the sum of all values, and n symbolizes as the total number of values. So next is getting the median. So what is median? Median is also called as the middle scorer value when the original data values are arranged in order to increase magnitude. So there are two ways to determine the value of median for ungrouped. So if n is odd, the median is the middle rank. But if Rn is even or even number, the median is the average of the two middle ranked value. So the formula that we are going to use in getting the median is x is equals to x sub 1, the quantity of x sub 1 plus x sub 2 over 2, wherein x is our median, x sub 1 would be the first middle value, and x sub 2 would be the second middle value. So next, let's talk about the mode. Mode is the value that occurs with the great frequency. So there are different types of mode. We have four different types of mode wherein we have no mode, unimodal, bimodal, and multimodal. So in no mode, our dataset values have the same number of frequency. For example, 1, 1, 2, 2, 3, 3, 4, 4, and 5, 5. So on those sets, we all have the same repeated values. We all have the same different same uh, repeated numbers rather in our data set. So next is the unimodal, wherein data set that has the only one value that occurs with greatest frequency. For example, 1, 1, 2, 2, 3, 3, 3, 4, 4, and 5, 5. So our 3 here in this dataset is repeated 3 times. And it occurs that our number 3 in our dataset has the greatest frequency, so it is a unimodal. So third is the bimodal. Bimodal has a dataset of two values with the same greatest frequency. For example, 1, 1, 1, 2, 2, 2, 3, 3, 4, 4, and 5, 5. So our number 1 and 2 has the same greatest frequency, so therefore it is called bimodal. So fourth is the multimodal. If a dataset has more than two modes, so here it explains that if, excuse me, if our dataset has uh, more than two numbers that occurred with greatest frequency. So if our dataset has more than two modes or more than two number values that has the or that occurs with greatest frequency, therefore it is called multimodal. So next, we also have formulas for getting the group data. So in group data, we will be having a table or frequency distribution table to get the mean, median, and mode. So in mean, we have a formula of x is equals to summation of f sub I x sub I over n, wherein our f sub I is the frequency, x sub I is the class mark, and n is the total frequency. So to get the median, we have x is equals to ln plus n over 2 minus cb sub f divided by fgi multiplied by I, wherein Ri is the size of class interval, n is the total of all frequencies, Fgi is the frequency of medial class, Cb sub f, Cf sub b rather, would be the sum of all frequency below medial class Lm, and RLm would be the lower class boundary of the medial class. Excuse me. So for our mode, we also have a formula for getting the mode in a group data. So we have x is equals to L plus H multiplied by f sub fm minus f sub 1 over fm minus f sub 1 plus fm minus f sub 2, wherein our f sub 2 would be the frequency of class following to the modal class, f sub 1 would be the frequency of the class preceding to the modal class, fm would be the frequency of modal class, h would be the size of class interval, and L would be the lower limit of modal class. Now, let's also talk about the measures of dispersion. So in measures of dispersion are non-negative real numbers that help gauge the spread of the data about a central value. So in this measure of dispersion, it helps to determine the the spread or the squeeze in the given data. So there are five most commonly used measures of dispersion. These are range, variance, standard deviation, mean deviation, and quartile deviation. So in our measures of dispersion, we have it is classified into two, which is the absolute and the relative dispersion. So in absolute dispersion, it says here that if the dispersion of data within an experiment has to be determined, then absolute measures of dispersion should be used. These measures usually express variations in a dataset with respect to the average of the deviation of the observation. So here it only focuses on one unit, and under that, under this absolute dispersion is the range, variance, and standard deviation. So in order for us to measure the average or the expressed variations in a data set, we will gonna use these three because these three are connected to get our hmm, to get our data in a specific unit. While in relative measures of dispersion, it explains here that measures are expressed in the form of ratios and percentage, thus making them unitless. So can we can simply compare our observation or our observation or our uh, measurements in one unit to another unit we because in this relative measure of dispersion we are talking about no units the in finding a data. So next, so measures of association. So in measures of association, it talks about the relationship of two variables. So measures of association is branched out into two, which is the chi-square and the correlation. So in chi-square, it used on nominal data to determine whether they are associate. So we have variables that is let's say for example, I have I have a variable um wherein losing a ball pen could highly affect my academics. So so in chi-square, these two variables can be determined if they are really related to each other or connected to each other. So in order for us to identify if it's connected, we can we can know or we can simply know if it's significant or non-significant. So insignificant, it explains here that or if it explains here that if those variables, if we run a test on those two variables and we proved that these two variables are connected or related to each other. Therefore, it is significant. But if those two variables are proven that they are not connected to each other or they are not associated to each other, therefore it is non-significant. So next, correlation. Correlation used to measure the strength of the relationship between numeric variables. So here it explains the relationship of two variables with the use of numerical values. So in positive correlation, if the coefficient is between 0 and 1, one variable increases and other one also increases. So here we, for example, if we run a test and then we prove that the value of those two, if it's graphed, the value of those two, if it's graphed, is between 0 and 1, therefore it is positive correlation. But if those variables are proven that are, no, that if those variables are shown in the graph that they are between -1 and 0, therefore this is called a negative correlation because in negative correlation, one variable increases and the other one also increases. So if we graph um, the results of the test that has been done, you can we can simply visualize that our correlation is going downwards, which indicates negative correlation. I'm sorry. So that is where my part ends. I hope you learned something from me and God bless.